Welcome to the next episode of Thermodynamics. Today you are going to learn about gas laws. There are three gas laws which describe relationship between pressure, volume and temperature of an ideal gas. An ideal gas is gas which has the next three properties. So an ideal gas. A. Volume of molecules in a gas sample has to be negligible compared to volume of the container it is enclosed in. So volume of a gas which is enclosed in some container has to be much smaller than volume of that container. B. Average kinetic energy of gas particles has to be much greater than their potential energy so as to neglect intermolecular interactions. So average kinetic energy EK bar has to be much greater than average potential energy EP bar. And C. Collisions between gas molecules and the container wall are perfectly elastic, so collisions without loss of kinetic energy. So collisions, gas particles, container wall, are perfectly elastic. So these are conditions a gas has to fulfill in order to be an ideal gas. In each of the gas laws we are going to talk about are included these three main quantities: pressure P, volume V, and temperature T in kelvins. Of the gas of the constant amount of substance small n. In each of them, one of these three quantities is constant. These three quantities are found in an ideal gas equation, which is PV equal to nRT. So an ideal gas equation, one of the most important ones in thermodynamics, which is derived from the value PV over T, so product of pressure and volume divided by temperature in kelvins, which is constant value. So it is constant. And we can see here this big R. Big R is so-called an ideal gas constant, and it is approximately, so it is calculated from the standard gas conditions using the constant PV over T, and it is approximately 8.314 joules per mole Kelvin. So it is ideal gas constant. And now we have these gas laws. So the first gas law is Boyle's law, which describes an isothermal process. This means that in this isothermal process, temperature is constant, meaning that change of temperature delta T is 0, but pressure and volume do change. So PV do change, and their product P times V, PV, is constant in an isothermal process. The second gas law is Charles' law, which describes an isochoric process. A process where volume V is constant, so volume does not change, delta V is 0, but P and T do change, so P over T is constant. And finally, the third gas law is Gay-Lussac law, which describes an isobaric process So it describes process. Isobaric process is process where pressure P is constant, so its change delta P is 0, but volume and temperature do change, so V over T is constant. For each of these processes, we can go and draw 3 graphs representing 3 different dependencies, which are a combination of these 3 basic quantities P, V, and T, so pressure, volume, and T temperature in kelvins. A VT graph, so volume temperature dependence, which describes how does the volume of a gas depend on its temperature in kelvins. A PV graph, pressure volume dependence, and a PT graph, pressure temperature dependence graph. So let's have these 3 columns, VT, PV, and PT graph, and mark this axis. So VT graph, PV graph, and PT graph. And we are going to draw them for each of these 3 processes. Each line we are going to draw is going to be a function of or a graph of that process. So isotherm is named for line of equal temperature, isocore represents equal volume, and isobar equal pressure. So we have each of these 3 graphs for each of these 3 processes. First is isothermal process where temperature T is constant, so also PV is constant. Then isochoric process where volume is constant, also P over T is constant. And finally isobaric process where pressure is constant, so also V over T is constant. And now first let's take this isothermal process. So first we have VT graph. Temperature is constant, so it will be this graph, which is actually a line, a straight line parallel to y-axis. It is perpendicular to t-axis because temperature does not change. PV graph, we have that P times V is constant, so P times V, greater pressure is smaller volume, or smaller pressure, greater volume. So we have this inverse proportionality, which is exponential. So we have greater volume, but smaller pressure, smaller volume, but greater pressure. And finally PT graph, where again temperature is straight line, as on this first VT graph, because temperature is constant, it does not change in an isothermal process. And so now we have this isochoric process where volume is constant. So volume is constant, it does not change. Here we have volume and it is constant. PV graph, here we have this volume and volume is constant, so straight line. And finally P over T is constant and it is linear dependence and normal proportionality. So greater pressure, greater temperature, and vice versa, greater temperature, greater pressure, and it is straight line. Finally, we have an isobaric process where pressure is constant and V over T is direct proportionality, so greater temperature, greater volume. Again, straight line, similar to this graph. In PV graph for P, pressure is constant, so this is this straight line parallel to V-axis, it is perpendicular to P-axis. And finally the same graph for PT graph for an isobaric process. That's all for today. Now you can take a quiz to test what you've learned in this video. You can find the link in the description of the video. Thanks for watching and stay with us.